Hello friends, welcome to my YouTube channel Power Plant Practical Knowledge. ಲಾಸ್ಟ್ ವಿಡಿಯೋದಲ್ಲಿ ಡಿಯರೇಟರ್ ಅದರ ಪ್ರಿನ್ಸಿಪಲ್ ಏನು, ಆಪರೇಷನ್, ಮೇಂಟೆನೆನ್ಸ್, ಅದ್ರ ಪ್ರಾಬ್ಲಮ್ಸ್ ಏನು ಡೀಟೇಲ್ ಆಗಿ ಡಿಯೇಟರ್ ಬಗ್ಗೆ ತಿಳ್ಕೊಂಡಿದ್ವಿ. ಈ ವಿಡಿಯೋದಲ್ಲಿ ಡಿಯೇಟರ್ ಸ್ಟೀಮ್ ಕ್ಯಾಲ್ಕುಲೇಷನ್ಸ್ ಅಂದರೆ ಡಿಯೇಟರ್ಗೆ ಬೇಕಾದ ಸ್ಟೀಮ್ ಕ್ಯಾಲ್ಕುಲೇಷನ್ಸ್ ಇನ್ ಡೀಟೇಲಾಗಿ ತಿಳ್ಕೊಳ್ಳೋಣ. ಪ್ರಾಕ್ಟಿಕಲಾಗಿ ವಿತ್ ಸ್ಟೆಪ್ ಬೈ ಸ್ಟೆಪ್ ಫಾರ್ಮುಲಾಸ್, ಪ್ರಾಕ್ಟಿಕಲ್ ಎಕ್ಸಾಂಪಲ್ಸ್ ಪ್ಲಸ್ ಪ್ರೋಸೆಸ್ ಪ್ಲಾಂಟ್ನಲ್ಲಾದರೆ ಯಾವ ರೀತಿ ಸ್ಟೀಮ್ ಕ್ಯಾಲ್ಕುಲೇಷನ್ ಮಾಡಬೇಕು, ನಾನ್ ಪ್ರೋಸೆಸ್ ಪ್ಲಾಂಟ್ಸ್ ಆದರೆ ಯಾವ ರೀತಿ ಮಾಡಬೇಕು, ಈ ಡೀಟೇಲಾಗಿ ಈ ವಿಡಿಯೋದಲ್ಲಿ ತಿಳ್ಕೊಳ್ಳೋಣ. ನಮ್ಗೆ ಈಗಾಗಲೇ ಇಂಪಾರ್ಟೆನ್ಸ್ ಆಫ್ ಸ್ಟೀಮ್ ಇನ್ ಡಿಯೇಟರ್ ಗೊತ್ತಿದೆ. ಬಿಕಾಸ್ ಇಟ್ ಈಸ್ ರಿಕ್ವೈರ್ಡ್ ಟು ಹೀಟ್ ಫೀಡ್ ವಾಟರ್ ಟು ರಿಮೂವ್ ಡಿಸಾಲ್ವ್ಡ್ ಗ್ಯಾಸಸ್. ಇಟ್ ಆಲ್ಸೋ helps us to reduce chemical consumption and cost. Also helps us to increase boiler efficiency. But ಇದೆಲ್ಲನೂ efficient ಆಗಿ when it is possible when we use right quantity of steam at right pressure and temperature. Then only deaerator efficiency and the cost will be optimized. Types of steam available for deaeration: LP steam or extraction steam. Non-process ಪ್ಲಾಂಟ್ನಲ್ಲಾದರೆ ಎಲ್ ಪಿ ಟಿಗೆ ಹೋಗೋ ಸ್ಟೀಮ್ನ ಒನ್ ಆಫ್ ದ ಎಕ್ಸ್ಟ್ರಾಕ್ಷನ್ ವಿಲ್ ಬಿ ಟೇಕನ್ ಆ್ಯಂಡ್ ಇಟ್ ವಿಲ್ ಬಿ ಡೈವರ್ಟೆಡ್ ಟು ಡಿಯೇರೇಟರ್. ಅದೇ ರೀತಿ ಶುಗರ್ ಪ್ಲಾಂಟ್ನಲ್ಲಿ ಬರೋಷ್ಟೊಟ್ಟಿಗೆ 3 ಆಟ ಎಕ್ಸ್ಟ್ರಾಕ್ಷನ್ ಇರುತ್ತೆ. ದಟ್ 3 ಆಟ ಎಕ್ಸ್ಟ್ರಾಕ್ಷನ್ ಕ್ಯಾನ್ ಬಿ ಯೂಸ್ಡ್ ಫಾರ್ ಪ್ರೋಸೆಸ್ ಆ್ಯಂಡ್ ಆ್ಯಸ್ ವೆಲ್ ಆ್ಯಸ್ ಡಿಯೇರೇಟರ್ಗೆ. ಅದೇ ರೀತಿ ಆಕ್ಸಿಲರಿ ಸ್ಟೀಮ್ ಸ್ಟಾರ್ಟಪ್ನಲ್ಲಿ ಮೇನ್ ಸ್ಟೆಮ್ ಲೈನಿಂದ ಒಂದು ಟ್ಯಾಪಿಂಗ್ ತೊಗೊಂಡು ದಟ್ ಲೈನ್ ಥ್ರೂ PRDS ಇಟ್ ವಿಲ್ ಬಿ ಕನೆಕ್ಟೆಡ್ ಟು ಡಿಯೇಟರ್ ಆ್ಯಸ್ ಎ ಪೆಗ್ಗಿಂಗ್ ಸ್ಟೀಮ್ ಆರ್ ಫ್ಲಾಶ್ ಸ್ಟೀಮ್. ಡ್ರೈನ್ಸಿಂದ ಬರೋ ಜನ್ರೇಟ್ ಆಗೋ ಫ್ಲಾಶ್ ಸ್ಟೀಮ್ನು ಡಿಯೇಟರ್ಗೆ ಯೂಸ್ ಮಾಡ್ಬೋದು. ವೇರ್ ದಿಸ್ ಈಸ್ ದ ರೇರ್ ಕೇಸ್. ಮೇನ್ ಇಂಪಾರ್ಟೆಂಟ್ ಪ್ಯಾರಾಮೀಟರ್ ಸ್ಟೀಮ್ ಯೂಸ್ ಮಾಡೋದ್ರಿಂದ ದ ಪ್ರೆಷರ್ ಸೆಲೆಕ್ಷನ್ ಈಸ್ ದ ಮೋಸ್ಟ್ ಇಂಪಾರ್ಟೆಂಟ್ ವಿಚ್ decides the performance of deaerator and the steam consumption in the deaerator. In deaerator, boiler water gets heated based on law of conservation of energy, which states energy can neither be created nor be destroyed, but it can be converted from one form to another. Here, the live steam temperature with pressure which we are supplying to deaerator will heat the boiler feed water. Basic heat balance concept is equal to energy in is equal to energy out, where energy is the saturated steam we are giving and the feed water we are charging the deaerator. Output is equal to the heated saturated boiler feed water, where MS stands for steam flow, HS stands for steam enthalpy, MW stands for water flow, HW stands for water enthalpy, and HF stands for final saturated water enthalpy of boiler feed water. Simplified formula for steam calculation: MS equal to MW into HF minus HW divided by HS minus HF, where numerator is the heat required by the water, denominator represents the heat available from the steam, numerator by denominator. By this we can find out the quantity of steam required for deaeration in the deaerator. Next, we will learn the quantity of steam required for deaerator in non-process plants like steel plant, cement plant, where the process steam will not be charged for the process and there will be no loss in the return condensate. We'll take such example and we will learn the calculation step by step along with solution to find out the quantity of steam required. LP steam required to deaerator for deaeration at pressure 1.5 kg centimeter square and temperature at 135 degrees centigrade. Feed water outlet temperature from deaerator to be 105 degrees centigrade. Feed water outlet flow from deaerator 125 tons per hour. CEP water flow to deaerator at 50 degrees centigrade to be 120 tons per hour, and the makeup water to deaerator at temperature 25 degrees centigrade to be around 5 tons per hour. Data required for steam calculation from steam table: enthalpy of steam at pressure 1.5 ksc and 135 degrees centigrade is 653 kilocalorie per kg, and enthalpy of CEP water at 50 degrees centigrade is 50 kilocalorie per kg. Enthalpy of makeup water at temperature 25 degrees centigrade is 25 kilocalorie per kg. Enthalpy of deaerator outlet feed water at temperature 105 degrees centigrade is 106 kilocalorie per kg. Now we'll substitute these all parameters in the below mentioned formula. For non-process plants, mass of steam required will be calculated from the mentioned formula. Above numerator is the quantity of heat required, below denominator is the total heat available. For the non-process plants, the formula will be feed water flow into enthalpy minus CEP flow into enthalpy minus makeup water into enthalpy total divided by enthalpy of steam minus enthalpy of deaerator outlet feed water. By substituting above values in the formula, feed water flow 125 into enthalpy 106, CEP flow 120 tons per hour into enthalpy 50 minus makeup water 5 tons per hour into enthalpy 25 kilocalorie per kg, dividing it by 653 kilocalorie per kg enthalpy of steam minus enthalpy of deaerator outlet water 106 kilocalorie. The total mass of steam required for above deaeration is 13.02 metric tons. This is the steam calculation required for deaerator for non-process plants. For calculating deaerator steam requirement for process plants, we will consider sugar plant as an example. Sugar plant nalli turbine in the third extraction or 3 steam sugar process ಕೊಡ್ತೀವಿ. ಶುಗರ್ ಪ್ರೋಸೆಸ್ ಕೊಟ್ಟಾದಮೇಲೆ ಅಲ್ಲಿಂದ ವರ್ಕಿಂಗ್ ಮುಗಿದ್ಮೇಲೆ ಬ್ಯಾಕ್ ರಿಟರ್ನ್ ಆಗಿ ಕಂಡೆನ್ಸೇಟ್ ಬರುತ್ತೆ. ದಟ್ ವಿ ಕಾಲ್ಡ್ ಆಸ್ ಅ ರಿಟರ್ನ್ ಕಂಡೆನ್ಸೇಟ್. ಆ ರಿಟರ್ನ್ ಕಂಡೆನ್ಸೇಟ್ ವಿಲ್ ಬಿ ಅರೌಂಡ್ 95 to 98% of total steam supplied to the process. That will be around 95 will be the minimum temperature and maximum temperature will be around 118-120 degrees. ಆ ರಿಟರ್ನ್ ಕಂಡೆನ್ಸೇಟ್ನ ಬ್ಯಾಕ್ ಟು ಡಿಯೇರೇಟರ್ ತೊಗೊಳ್ತೀವಿ. We will learn the quantity of deaerator steam required in process plants. Deaerator steam at 2.5 kg and at 150 degrees centigrade. Considering feed water outlet temperature from deaerator at 128 degree, feed water outlet flow from deaerator 210 tons per hour, CEP water flow to deaerator at 45 degrees centigrade to be 30 tons per hour, makeup water to deaerator at temperature 25 degrees centigrade to be around 20 tons per hour, and the process condensate from sugar plant at 95 degrees centigrade to be around 160 tons per hour. After taking data from steam table, considering enthalpy of steam at pressure 2.5 kg per centimeter square and temperature 150 degrees centigrade to be 658.4 kilocalorie per kg, enthalpy of CEP water at temperature 45 degrees centigrade to be 45 kilocalorie per kg, enthalpy of makeup water at temperature 25 degrees centigrade to be 25 kilocalorie per kg, and enthalpy of deaerator outlet feed water to be around 129 kilocalorie per kg. Also considering enthalpy of return condensate from process water at temperature 96 degree to be around 96 kilocalorie per kg. This formula is used to calculate the quantity of deaerator steam required in process plants. Above is the heat required and below is the heat available. For calculating the quantity of steam required in deaerator, here feed water flow into enthalpy minus CEP flow into enthalpy minus makeup water into enthalpy minus return condensate into enthalpy. In process plant, return condensate enthalpy will be an additional parameter that we will be considering, whereas in non-process plant this parameter will be not be available. Whole total divided by enthalpy of steam minus enthalpy of deaerator outlet water. Now by substituting the values, 210 feed water flow into enthalpy 129 minus CEP flow 30 tons into enthalpy 45 minus makeup water 20 into enthalpy 25 minus return condensate 160 tons per hour into enthalpy 96. This divided by 658.4 enthalpy of steam minus enthalpy of deaerator outlet water 129. We get 18.66 metric tons. This is the quantity of steam required for process plants for the above values. These are the two methods for calculating steam consumption in deaerator for both in process plants and non-process plants. Now, what are the factors affecting steam consumption? Key factors are vent loss, continuous non-condensable vent gases releasing top of the deaerator, and heat loss due to radiation, poor insulation, and inlet water temperature variation, excess steam pressure. All these are the factors affecting the steam consumption in deaerator. Next, how to optimize steam consumption in deaerator. Maintain proper vent rate by 0.1 to 0.2%. Use maximum flash steam. Ensure proper insulation. Maintain tray cleanliness so that automation will be good. Optimize extraction stream pressure so that excess venting can be avoided. Common mistakes we make in deaerator steam consumption calculation or while operating are ignoring enthalpy values, using wrong steam pressure data, not considering vent losses, overheating of deaerator. These are the common mistakes we make in operation or while calculating the data. Deaerator steam calculation is simple when you understand heat balance, but real efficiency of deaerator depends on operation, maintenance, and optimization. If you found this video useful, please like, share, and subscribe. Please click bell icon for further updates. Thank you.